Okay, good morning everyone. I'll make use of my 10 valuable minutes. I'm Johann Marquez Barja. I'm a full professor at the University of Antwerp and also part of iMEC Research Center in Belgium. iMEC is a research center, it's a leading research center, it's a flagship research center in Belgium, in Europe actually, for two things, hardware and software. We go from the design of our chipsets up to cloud systems where we process the data, of course, including from generation of the data, the transportation, connectivity, and the process of it. We have presence all over the world, so we understand we are a research center, although we are extremely close to industry, and our solutions are adopted by industry. That's how our finances work. We have a presence in different markets in the world, so we understand or try to understand what industry needs, and then we research to deliver those solutions. There's an interesting model with these flagship research centers. They are really aligned to universities. When they need some expertise, they look where that expertise exists, and they basically sign an agreement between the center and the university. That's very interesting for us, for academics. I'm representing the group from iMEC called ID Lab, which is basically located in two geographical places in Belgium, in Antwerp and in Ghent. My colleague after me, Professor Adnan, is going to talk about the assets in Ghent. So in Antwerp, we have three assets that, well, we have several assets, but these three assets are the ones that we are going to bring in the projects that we are talking together. And by the way, the University of Antwerp is number 7 in the Young University ranking in the world. As I was mentioning before, we do hardware and we do the software part, and we apply to different industrial verticals. In the team that I lead, I'm the head of Programmable and Intelligent Networks at iMEC Antwerp. We apply our solutions to basically smart mobility, smart cities, and smart industries. What are those assets? We have 3 testbeds. There's smart city, 3 outdoor testbeds, and one of them is /indoor. So we have the smart city of Antwerp. We have the smart highway where we are connecting vehicles. I'm going to show you the coming slides. And we have an indoor that can be pushed outdoor all-run test bed. So we do have our own 3.5 frequency. We have our spectrum, the government of Belgium gave us a spectrum for research purpose, so we can deploy outdoor solutions for 5G, 6G in the smart highway. This is a real highway that gets into the city, the E313. We have it in the south of Antwerp, in the campus where we teach basically. And we have it in city center where a part of our labs are. So our research, it's really applied, and actually it's already impacting some civil, some societal areas. This is City Lab. Basically, we have 3 boxes. We like to call them the 3 boxes lab, because we have here computing capabilities, and here we have all the antennas that they offer us different ratings. The smart city has wide range coverage, so we do have our own, and we do have our own LoRa network, but we are associated with 2 telcos to cover the whole city. But that's for low power IoT in the city. And then we have the 3 boxes that I was mentioning, that they offer us short range and high capacity networks, ranging from Wi-Fi, Dash7, and of course with SDRs, we have deployed Open RAN there, and we are deploying improving it to even have millimeter wave. It's just a matter of updating our boxes. This is how it looks. These are in the very center of Antwerp. These are where our gateways, our 3 boxes are. Well, you see 2 here. The third one is indoor, where it's doing process. Um, are located in Antwerp. This is at the testbed where we research, and once the system is stable, we push it to the smart zone. Here, there's a lot of commercial areas that are using our services. So this is production network, and this is research network. An example of things that we have done with this flexibility that is radius, and the software that goes on top. This is a paper that we had. Basically, we are capable to control how open modes in the script, in the print script, how they should behave, and they are being controlled here from Chameleon. And to do that, we just run our scripts. We create a slice that stitches, well, that's a technical name, that merges assets in Antwerp, Ghent, our tier 1 for our edge computing, then tier 2 in Amsterdam, another country in Europe, and finally we cross the ocean and then we connect in these servers. So we have that capacity, that flexibility to stitch to different testbeds and to create a real network. So basically a network slice, a virtual network on top of this real equipment all over the world. There's a big association, Slices, we are part of Slices, and there was an association, Petrofire, that was connected to Genie here. So several use cases that we have run in the city because of our connectivity. I'm going to talk about this, about the smart highway, but basically we have smart traffic lights with mobility patterns. When the tram crosses, we know by default that people run behind, so our smart systems, they sense people, how they run behind the tram, and they put the smart traffic lights, they put in red to protect people. Those are one of the use cases that we show to the government, how their money is being used. Smart highway. The smart highway, basically, once we learn how to do things right in the city, we have done this, pushing this technology to the highway. So behind the game press, we had 7 kilometers of with these boxes every 600 meters, and these boxes have a lot of software-defined radio, and inside here we have powerful computing. So we have edge computing at the edge of the highway for our connected vehicles, and that gives us a lot of flexibility. So we do AI. All the learning is at the edge of the highway because the dynamicity of this use case demands something like that. This is the smart highway. So this is where our roadside units, basically our GNOVs, are located, and these are the vehicles that we have, all connected with sensors, powerful computing capabilities inside the vehicles, powerful computing capabilities in the highway. Things that we do there, for instance, we are capable to deploy services in the highway, orchestrate both things, the services, and orchestrate the intelligence that goes on top of these boxes along the highway in order to provide, this is something I'm going to talk about that, in order to provide always best connected services for dynamics and scenarios like connecting a vehicle. As I mentioned before, we have several testbeds. In Ghent, for instance, we have the tier 1 edge computing that we send more information. If we cannot do it here, we send it to Ghent, for instance. The flexible next-G open radio. Okay, that's it. It's basically what we all are exploring. Open RAN in a flexible scenario. We have our inside the laboratory that can, what we learn here, it can be pushed to the smart city or the smart highway. In the project safety Excel, we're going to push it to the smart city. What do we do? What do we have? Mix and match. So we do have different open source systems for the core, for the radio, for our rig, and we run experiments, just mix and match. Basically, we deploy one type of core, we deploy a different couple of different radios or runs at the same time, connected by the same core, or vice versa. So mix and match, and it's in pretty decent stable aspect. This is an indoor of our offices where we have vehicles, user equipment, etc., etc. We can push this technology to our vehicles, and we have also mobile systems that we can deploy in the port of Antwerp. And with this, I have shown you what we can offer to you in Antwerp. We are always open to work with different stakeholders and across the continent.